Alright, we are still working off the essential question. How can I use trig ratios to solve triangle problems? Yesterday you wrote the ratios and you did some calculator work, and then today you're going to use the ratios to find side lengths. So we are going today to find the value of x and y. We're going to be finding the value of x and y and get a right triangle on your paper. And that right triangle is going to have a 25-degree angle, an 18 length side, a side length of x, and the hypotenuse is y units long. So now whenever you're using these trig ratios, you want to have the acronym SOHCAHTOA written on your paper. Okay, so you get this problem. You're given this 25-degree angle. The first thing you want to do is name the sides. And you're going to name the sides in relation to the 25-degree angle. Now, the side opposite the 90, that's always the hypotenuse. The side that's next to the angle given is the adjacent side, which leaves side x here as the opposite side. So you've got your sides named, and now you're going to choose which variable you're going to solve for first. And I'm going to do these alphabetically, so I'm going to solve for the x first. Now, in relation to this given angle of 25 degrees, if I'm solving for x, and I'm given the 18, I'm going to be working with opposite and adjacent. I'm going to be working with the sides that are opposite and adjacent to the given angle. Opposite and adjacent is a tangent ratio. Now you write your equation. So the equation to solve for x here is going to be tangent of 25 equals the opposite side over the adjacent side. To solve for x, you multiply both sides by 18. These 18s cancel. And then in your calculator, it's 18 times 25 tan. And you should get 8.39. 18 times 25 tan. In these calculators, we got to put the angle measure in first and then the tan. Did you get 8.39? What did you type in your calculator? Okay, did you push equals? Yeah, you're probably not in degree mode then. You're going to have to go back to your mode button, get it in degree mode. If you didn't get 8.39, you're not in degree mode, or you typed in tan 25 wrong. In the TI-30XAs, you got to type in the 25 and then the tan button, and then hit equals. Better? Alright, so now we're going to solve for the y. So to solve for the second variable, you repeat the process. You've already named the sides. We're still using this 25-degree angle. Now we're going to be dealing with the hypotenuse and the adjacent. Okay? Hypotenuse and adjacent, or adjacent and hypotenuse. That's cosine. So your ratio now, or your equation, is going to be cosine 25 equals your adjacent side, which is 18, over the hypotenuse, which you're trying to find. Now, when the variable's in the denominator, you've got one more step to add here. Your first step is to get the variable out of the denominator, and you do that by multiplying both sides by y. The y's on the right, they cancel each other out. So you've got y times cosine 25 equals 18. And now you can isolate your variable by dividing both sides by cosine 25. Now your cosine 25s cancel out. And you can do this last step in your calculator. So now it's 18 divided by 25 cosine equals. You should get 19.86. Make sure, the most important thing for you right now, you guys that are having calculator issues, is that you got the equation written out and you know the steps to get to the last step. Alright? You know the operations to get to the last step. If you're having calculator problems, I can try to help you with those. Your calculator doesn't look like it's this TI 30XA that everybody else is using. So you may have it not set up the way you need it set up. Right now you need to focus on that. Being able to get from here to this step. Because when you get to this step, all you've got to do is this calculator operation. And I can show you how to do the calculator operation once we get done with this. Right now you got to be able to get to here. Okay? So let's try another one. Right triangle. Hypotenuse is x. Inside angle of 70. We got a side that's 15 and another side that's y. In relation to this 70-degree angle that we're dealing with, we're going to name the sides. The hypotenuse is always the hypotenuse. The other side that forms the angle is the adjacent side. So by process of elimination, that makes this side the opposite side. So I'm going to solve for these alphabetically. I'm going to solve for the x first. In relation to the 70-degree angle, we're going to be dealing with now hypotenuse and adjacent. Adjacent and hypotenuse is cosine. Cosine 70. Cosine of 70 equals the adjacent side over the hypotenuse. And that's, I'll multiply both sides by x. So x times cosine 70 equals 15. If you divide both sides by cosine 70, Your cosine 70s will cancel out, and your x will be equal to 43.86. Yes, question. That's the math operation you use to get the x out of the denominator. You use cosine of 70 because the two angles, or I'm sorry, the two sides you were working with to solve for x were the adjacent and the hypotenuse. And here's your cosine equals adjacent over hypotenuse. Your acronym tells you which ratio to use and what goes in the numerator and in the denominator. You use the cosine of 70 because the 70-degree angle was given, and you're working with the adjacent side and the hypotenuse. So now, when we go to solve for the y, we're still using the 70, right? But now, when we're solving for y, we're using the opposite side and the adjacent side. So when you're using opposite and adjacent sides, you need to use the ratio that deals with opposite and adjacent, which is tangent, because tan equals opposite over adjacent. So when you write that equation, now it's tan 70 equals the length of the side opposite, or the opposite side, which is y, divided by the length of the adjacent side, which is 15. When your variable's in your numerator, it's just a one-step equation. You multiply both sides by 15 here. These 15s on the right cancel. So 15 times 70 tan, you should get 41.21 equals y. Does that make more sense? TOA is the acronym for tangent equals opposite over adjacent.
So which two sides you should use? Like, I know the 70, but how do I know the difference between when I need to use the hypotenuse and the opposite, or the hypotenuse and adjacent?
Very good. Good question. If you wanted to solve for the y first, you couldn't use opposite and hypotenuse because neither one of them have a value. So if you were solving for y first, you're going to use a side length that's given and a side length you're trying to find. Then when you go to find your other side, you see how both of these sides are rounded and we're only dealing with 2 decimal places. When you're going to find your side lengths, always use one of the sides that's given because it's a whole number, it hasn't been rounded, and you're going to get a better answer. Right? Does that answer your question?
It's like, I can't really tell the difference when I know what the acronym stands for.
Okay.
When I'm dealing with the 70, with the hypotenuse and adjacent, it still doesn't really make sense.
All right, good. Let's do another one. Here, let's get a triangle. And, let me see some side lengths. I can make them up. Let's do a 19-degree angle. and a side that is 7. And we're going to go x and y. All right, so step by step, you know you're going to use this 19-degree angle, right? Now, you're going to name the sides. In relation to the 19-degree angle, what's the y going to be called? Y side. It's your hypotenuse. What's the x side? It's your adjacent. So that makes the 7 side your opposite. Now, you just ask yourself, what side do I want to solve for next? All right, so which one do you want to do? You want to solve for the x variable. Okay, so if you're going to solve for this x variable, it's the adjacent side. The other side length that's given is the 7, and it's an opposite side. So you're going to be working with a ratio that deals with adjacent and opposite, or opposite and adjacent, which is what? Tan, or TOA, yes. So you have to use this ratio. You got to use your 19, your x, and your 7. So you use the TOA acronym that tangent equals opposite over adjacent. So tan of 19 equals the opposite side, which is 7, over the adjacent side, which is x. Better? Now you just do your math operations to isolate your variable. So you got to multiply both sides by x. These x's cancel. You're going to divide by tan 19 next. The tan 19's cancel. So your x equals 7 divided by 19 tan. 20.33. So now we've got all the sides labeled. We're still going to use the 19-degree angle. We're going to solve for y, which is the hypotenuse, and we're going to use that same given side, 7, which is the opposite side. So which ratio deals with opposite and hypotenuse? Sine equals opposite over hypotenuse. So we got to use sine. So now your sine of 19 equals your opposite side, which is 7, over your hypotenuse, which is y. And repeat that process. You're going to multiply by y. Those cancel. You can divide by sine 19. And your y is going to be equal to 7 divided by 19 sine. 21.5. Better? Okay, good. Questions? All right, here's your assignment for today. It's in blue.